Senior Design Showcase presentation for the Hinco project. And the company that we worked with is Hinco. Hinco is a company based in Lincoln, Nebraska that specializes in injury consulting for companies of all sizes. Hinco provides on-site injury prevention and management solutions, helping organizations reduce workplace injuries, improve employee well-being, and cut down on healthcare costs. For this project, we centralized data and applied machine learning to identify patterns that could predict injury. And we worked with two manufacturing companies, one based in New Mexico and the other based in Iowa, to assess if predictive modeling could enhance their injury prevention strategies. And for our stakeholders, our sponsors include Kristen Hodge, who is the owner of Hinco, and Matthew Rhodes, who is the Global Director of Environmental Health and Safety at the New Mexico Manufacturing Company. For the faculty, staff, and coach, our project manager was Melanie Kugler-Wright, our tribe lead was Vinod Variam, and our coach was Addison Higley. For the student team, our development manager was Sam Gittleman, our product manager, me, and a developer, Dylan Bonner. And Landon Nuss, Colton O'Neill, and Jacob Sauer were also all developers of the team. And for the problem and opportunity, the problem that Hinco gave us was that Hinco collects data in different areas such as physical screening of employees, ergonomic analysis of the production systems, job hazard analysis of different jobs, and many more data. It is then the job of Hinco to review this information and strategize with the client the best way to prevent injury. And the opportunity that we had was this project aimed to centralize all of the different data. It used machine learning to find potential predictive modeling of injury to better allocate resources and make improvements to the workplace. Now I'll pass it off to Sam to show off our product solution.
Thank you, Francisco. So this is one of the functions of our app. This is the generate report option, and what this does is it takes in two sets of data. The first one is the injury data, which is the data we get from the companies, and they'll say, here are the injuries you've had, here's how they happened, here's when they happened, all the stuff like that. And then we've also got environmental data we got from a wearable device company. So we worked with this wearable device company as well, and what they do is they produce kind of sort of armbands that workers in these workplaces can wear, and it will passively collect data such as the heat, the sound dosage, the humidity, the pressure, stuff like that. And then it can also detect if the workers are doing something that could hurt themselves, such as repetitive motion or like a high force push-pull motion. And so we have data from those devices too. And so we're able to do some statistical analysis on both the injury and the wearable data, such as the nature of injuries. And then down below, we've also got stuff like the work roles of the people who are getting injured and the types of indicators. The indicators are like when the wearable will say, hey, there's too much heat, or hey, you're doing too many push-pull motions, and then it'll mark it as a risk. Okay, go next slide. So this is one of our machine learning models. This one is the restricted time model. And this one had an accuracy of 82% and then a Alcaroc score of about 90%. And what the Alcaroc score is it's another measure of accuracy. And it basically just differentiates, like, can the machine differentiate a positive from a negative? It's kind of more suited to the binary classification that we did for this model, where what it does is it predicts if a injury resulted in restricted time, and restricted time is if the injury left the employee unable to do all of their work duties, or if they would be restricted in what they could perform after the injury. And so this one had a pretty good accuracy on Alcaroc. We also have some features here. The first one is body part. That was the one that they found most important. And then the other ones are occupation, claim description, which is just the description of the injury, and then the nature of the injury. And then on the right there is a matrix basically displaying our predictions. So the zeros are negatives or there's no restricted time, and then the ones are positives or there was restricted time. And so we can see that the yellow ones are the correct prediction in this case. So you have 46 correct predictions and 10 incorrect predictions. Final one here is our LLM, or our large language model. This one we use to make predictions on data that we couldn't quantify. For example, we had some job hazard analysis forms that we had, which what they are is it takes some of the risks that certain jobs may have. For example, an assembler may be susceptible to push-pull motions, and it also have how to kind of prevent that risk from happening. And then, so we can throw that stuff, the stuff you can't really quantify into numbers in the LLM, and it will, we can put a prompt in there, and then we will get an output from the LLM as well. All right, finally, some values on highlights. Some of our highlights is we centralized wearable technology data and injury data. So a lot of our project was spent working with data that we were unfamiliar with. We had to mimic it, combine it, and do a lot of kind of stuff with it. And so we were able to get a lot of experience with that. I created machine learning models with good accuracy prediction. So the restricted time model you saw earlier had about 90% OCROC. The hour injury day model, which is another one, had also, I believe, high 80s in the OCROC. And so we were very happy with how those machine learning models went. Then built and integrated a large language model. With that one, we were able to implement that into our app, and we were happy with how it turned out. And for our learning opportunities, we gained insight into the importance of clear and proactive communication with our sponsor. We kind of weren't communicating with our sponsor as much as we should have been in the early stages, and then we were able to kind of rectify that because that was causing some problems with our understanding and the sponsor's understanding. And so we were able to kind of work on that, and then we got a lot better throughout the year. And finally, we learned the importance of understanding sponsors' priorities. Sometimes we're working on things that the sponsor didn't really want to prioritize, and so we were able to take her feedback and then kind of pivot and work on something more important. And that's all I've got. Thank you for coming, and then if you want to learn more, please stop by our booth on the second floor.